fraction. If this number here wouldn't be here, we'd be able to cross multiply. But because we do have this additional term there, we cannot cross multiply. So what we're going to look at trying to do is eliminate the fractions in the very first step. We want to multiply through by a value that will get rid of every single denominator. So what you're going to want to do is make sure all your denominators are factored, and because there's no plus or minus in any of the denominators, they're already factored. So we're looking for a least common denominator. So we need something that'll cancel with all the terms down here. So we're going to need something to cancel with an x. Well, the only thing that cancels with an x is an x. Then we need something to cancel with the 5. Well, that would be a 5, so this would be a 5x. And then obviously we already have an x to cancel with the x, so your least common denominator is 5x. So that's what we're going to multiply through all your terms by. We're going to multiply this side by 5x and this side by 5x. So both of these terms here get multiplied by 5x. Well, 5x times 5 is going to get you 25x. And then 5x times 5 over x. Here, this x is going to cancel with that x, which leaves you with 5 times 5, which is 25. Okay, and then that equals the other side. This 5x cancels with that 5, and that just leaves you with 5. Okay, so then here we have a algebra 1 problem. We just need to get x by itself, so we need to bring the 25 over. So this gets you 25x equals, subtract 25 from 5, and you get negative 20. And then we divide both sides by the 25 to get x by itself. So x equals negative 20 over 25, which is negative 4/5. So if you take the factor of 5 out of both of those. And now we need to check for our domain. Here, the value of x that would make 0, x0 is 0. And 5 times what number gets you 0? That's also 0. So for your domain on this one, this is x such that x can't equal 0. Okay. And since x was equal to negative 4/5, that is an acceptable solution. Okay. For number 4, here, again, we need to make sure everything's factored. And this is added together, so that's grouped. There is no GCF here, and it's not a difference of squares, so that's already factored. X minus 3, same thing, already factored. But here we have x squared minus 9. There's not a GCF, but oh, look at that. This is a perfect square, this is a perfect square, and that's subtraction. That would be a difference of squares, which does factor into conjugates. So that's x minus 3, x plus 3, and we should be getting very good at that at this point in time. If not, we really need to be coming in for help. So then here we need to come up with your least common denominator, your LCD. So we're going to need something that cancels with an x plus 3. Well, the only thing that cancels with an x plus 3 is an x plus 3. We need something to cancel with an x minus 3. Well, the only thing that can cancel with an x minus 3 is an x minus 3. And then for this denominator, it looks like those two terms are the same two terms I already have. So we have our LCD. So that's what I'm going to multiply through this side and this side by. X plus 3, x minus 3. And here, x plus 3, x minus 3. And it might not hurt if you wrote it twice over here, once next to each of these fractions. Because this fraction is going to get multiplied by that, this fraction is going to get multiplied by that, and this fraction is going to get multiplied by that. Okay? So when we multiply this fraction, this x plus 3 cancels with that x plus 3, which leaves you with an x plus 3 times an x. So that's x times x minus 3. Then we have a minus here, and then this x minus 3 cancels with this x minus 3, which leaves you with an x plus 3 and an x. So this is x times x plus 3. And then on the other side, we have an x minus 3 and an x plus 3, and that's what we're multiplying by. That's a minus there. So this cancels with that, this cancels with that, which just leaves you with the x squared plus 9. So now we need to distribute this to both terms. So here we get x squared minus 3x. This is actually a negative x that's getting distributed, so that's negative x squared minus 3x equals x squared plus 9. Then, looks like we have an x squared minus an x squared. Those can cancel each other out. Negative 3x and negative 3x get you negative 6x equals x squared plus 9. And now it looks like we have ourselves a quadratic. So if you have a quadratic, if you have an x squared in your problem here, we're going to have to set this equal to 0. So x squared, bring the 6x over to this side, you get positive 6x plus 9. Now we've got a very nice quadratic here, and the easiest way to solve a quadratic, assuming it factors, will be with factoring. So first term in each has to get you x squared, so that's x and x. Last term in each has to get you a 9, and it has to add up to 6, so that would be 3 and 3. All the signs are positive, so these are both plus. So your solution here, x plus 3 has to equal 0, so x equals negative 3. But on here, we need to check our domain. And if we go back and check our domain here, if we look at this term here, this was an x plus 3. Well, what would make that 0? That would be x could not equal negative 3. And then here, this is an x plus 3, so what would make that 0? Well, that would be x could not equal positive 3. And these are the same two factors, so these are our bad values. So for your domain on this one, you have x such that x can't equal 3 and x can't equal negative 3. And if we look, that's what we had, so that can't equal negative 3. So this one, since there's no other options, is a